Hello everyone, welcome back to Explore Electronics. In the previous video I have given the complete solution for set 1 model question paper of basic electronics subject. You can see in this playlist. Now let us see the answers for model question paper for set 2 in the same subject basic electronics with the code 22 BBEE103/23. Here the first question is explain forward and reverse characteristic of semiconductor diode. This question is very important. It is also asked in the set 1 question paper also. So with the question, in this question paper they have given PO, CO, Bloom's taxonomy level, and the last column is marks. So this is marks, and PO means program outcomes. Since this basic electronics subject related to EC, there are particular program outcomes defined for electronics branch. So this question come under 1 and 2. COs, coming to COs, it is course outcomes. For basic electronics subject they have defined 4 to 5 COs, you can see in the syllabus copy, and this topic or the diode comes under first CO. That's why they have mentioned PO and CO here. And coming to Bloom's taxonomy level, you need to carefully observe what is the Bloom's taxonomy level they have given in the question paper. If it is 2, this question is restricted for explanation. No need to analyze the circuit or no need to analyze the more things. If it is 3, you need to write the analysis or you need to derive the things like that. If it is 4, it is of design kind. So as Bloom's taxonomy level increases, the weightage of the question or the way of answering increases to the depth. So since it is 2, this question will be in the level of explanation. So you need to explain forward bias and reverse bias characteristics with the characteristic curve and explanation related to that. This carries 8 marks. And explain positive half wave rectifier with input and output waveforms. Here you need to first write what is half wave rectifier. Half wave rectifier will be consisting of one diode, and the output of the half wave rectifier will be like this. What happens in the positive half cycle and what happens in the negative half cycle. And you need to write how actually the output will be generated. This red line is the output, this is the blue line indicating the input signal we are applied. And here also you can see the Bloom's taxonomy level is 2. No need to worry about these two. You just go through the POs and COs given in your syllabus, and this need to be carefully looked at while writing the answers. And this is for 6 marks. And explain Zener diode as voltage regulator with no load. No load condition in the sense there is no resistor over here. When there is no resistor, you need to explain what is the current flowing through the diode. First, before going to that, explain Zener diode as a voltage regulator. What happens when Zener diode is connected in reverse biased fashion, and it will be operated with a particular voltage for which it is manufactured, that is Vz, and to that voltage it is going to regulate the voltage. And you need to explain what happens when there is no load. This is the current we are going to get at the no load condition. This is also a Bloom's taxonomy level 2 question. You need to just explain with some circuit and explanation and expression. Explain RC pi filter. Again, this is also a level 2 question. This carries 8 marks. This is the circuit. Here is the bridge rectifier shown at the starting. The second half of the circuit is RC pi filter. This consists of an RC network. There are two capacitors C1 and C2. C1 across voltage is VC1, C2 across voltage is V0, that is also across RL. So here you need to write what is the relevant expressions, peak voltage and the output voltages, and you need to explain how this pi filter is going to eliminate the ripples. So this carries 8 marks. Circuit may carry 2 to 3 marks, and explanation may carry 4 marks, and remaining 2 marks will be for the expressions. Explain DC load line analysis for a semiconductor diode. Here you need to write the circuit with diode, and this is the current limiting resistor at the input side, and you need to write the expression first, the total applied voltage E, or you may take this as V also, whatever. E is equal to IF into R1, that is the forward voltage into the current flowing through the resistor, and VF is the forward voltage across the diode. Here we need to consider the two extreme cases. Suppose if Vf is equal to 0, means in the x-axis we have taken forward voltage, in the y-axis we have taken forward current. So we need to take two extreme cases, that if this Vf is equal to 0 once, if this If is equal to 0 once, then we are going to get two expressions. These two expressions pointing point A and point B, or else you can see here, this is Vf, this is the expression for Vf is equal to E. This second expression is the point over here, and this first expression is the point over here. So If we are going to get as the maximum E divided by R1, and Vf we can get maximum as equal to E. When we are going to draw this line, this is the output characteristic of a diode, and when we are going to get these 2 points and draw a line, it is going to intersect over here. This will be called as Q point. We need to bias the device to this particular voltage and currents. That is what the DC load line is. You need to explain this much for 8 marks. Write down the characteristics of Zener diode. Already Zener diode question is asked previously. You can also write this answer over there to explain the Zener diode. This is the characteristics of Zener diode. This is the symbol of the Zener diode. And here is the point Vz. You are not supposed to forget to explain this point. What happens when the reverse bias voltage Vz is applied to the diode? And Iz maximum and Iz minimum are the 2 points where current can be varied when reverse voltage is constant at this point. And you need to explain in the forward bias, Zener diode is also worked as a normal diode. This carries 4 marks. Again, you can see here level is 2. This is just an explanation question. Explain BJT current amplification for increasing and decreasing IB levels. IB means base current levels. So here they have not asked particularly common base or common emitter you are going to choose. You can choose any kind of amplifier configuration. Here I have chosen common emitter amplifier. In the common emitter amplifier, this is the circuit NPN transistor and PNP transistor. If you are going to use, you can write any of these two circuits. And if you write the common emitter amplifier output characteristics for different values of IB, you can show how the IC and VCE curve is going to vary. And amplification factor beta is equal to IC by IB. IC is the output current, IB is the input current. What happens when IB varies? You can see here, IB is 5 microamperes. The current will increase up to here. From there onwards, if we increase VCE for this IB, the current IC will be constant. Similarly, you need to explain, suppose if you keep IB is equal to 10 microamperes at the input side, if VCE increases further up to this point, IC increases and then it becomes constant. Like this you need to explain, and also you can write beta may range from some 50 to 200, 50 to 200 value. Beta will be always greater than 1. You need to explain these things since it is an amplification factor. Explain common base input characteristics of BJT. Here they have asked common base configuration and only asked the input characteristics. And common base configuration circuit, again using NPN or PNP, you can write one of these two circuits and write which are all the input and output parameters of this circuit. And then coming to input characteristics means input voltage and input current taken into X and Y axis by keeping the output voltage constant, that is VCB. For two different values of VCB I have shown here. What happens here? If VEB increases, what happens here? IE also increases for a certain VCB. That is why here the curve you can see here, it is keep on increasing up to some extent of VEB, it is going to increase, and the resistance Rin at the input side will be equal to change in VEB divided by change in the current when VCB is equal to constant. Explain the working of N-channel JFET. This question is asked in the previous question paper also, means the model paper set 1. You can write the general circuit, then you can write with no bias and also with full bias condition, means when VGS is applied. So, and you need to explain the characteristics, what happens when VDS is increased from this point to this point, and you need to explain the saturation region of the JFET, the current becomes constant, and also in the ohmic region as VDS increases, current will be increasing for a particular VGS, and ID it will be in milliamps since the current flowing through the JFET in milliamps. You need to explain that. Explain the operation of enhancement type MOSFET. depletion mode and enhancement mode, two types are there. Here they have asked enhancement type MOSFET. This question is also very important, asked in the previous paper. Here the MOSFET is going to operate in three regions: cutoff region, non-saturation region and saturation region. So these are the conditions for three regions. When VGS and VDS are in this region, this voltages, the transistor will be operating this regions. You can see in the characteristic curve, when VDS is less than VGS minus VT, when this satisfies, this will be the non-saturation region. Current will be increasing, and then after, when VDS is increased further, the current becomes constant. You can explain this much for 8 marks. And this is also an same thing with some values given in the x and y axis and also for VGS. Draw the DC load line for transistor and identify Q points. Here just they have given transistor, it is not BJT or MOSFET or JFET they have given. Just take it as a BJT and write configuration with respect to common base or common emitter amplifier. And here also we need to write the expression for output VCE. VCE is equal to VCC minus ICRC. With taking this as expression, and we need to take the two extreme cases. Here IC is the current, output current, VC is the output voltage. So when IC is equal to 0, what happens? When VC is equal to 0, what happens? Then we are going to get 2 points. This point VCC divided by RC is the maximum IC, and also we are going to get maximum VCE, that is VCC. When we draw this line for the output characteristics, then we are going to get the operating point over here. So this is what how to set the Q point. And also suppose if we have other curve over here, this is for different IB, this is for IB1, this is for IB2, let us take. Here Q point will be over here. Since they have given identify Q points, you can write two more curves like this. This is for IB3 and this will be the Q point. Likewise, you need to explain the different Q points, how we are going to get for different values. Explain common emitter input characteristics. Again, common emitter circuit you are supposed to write any of these two, and you need to write which are the input and output parameters, current and voltages. And input characteristics is this: IB is the input current, VBE is the input voltage. As VBE increases further 0.7 volts, since this is the threshold voltage for the BJT, after 0.7 volts of base voltage, the current will start to increase. If VCE is set as 1 volt, this is the curve. If VCE is set as 10 volts, this is the curve. Explain the block diagram of typical op-amp. Op-amp block diagram will be having 4 stages: input stage, intermediate stage, level shifter stage, output stage. Here each and every block will be consisting of an amplifier stage, some emitter follower amplifier or unbalanced differential amplifier, so push-pull amplifier. So you need to explain each and every stage will be consisting of what component and what is the functionality of that. And if they ask to write the internal circuit of the op-amp, you can write this. Otherwise no need to write this, only explanation for this is sufficient. Explain the working of differential amplifier. Differential amplifier in the sense, basically op-amp will be a differential amplifier. Means what? When we are going to apply the voltage for V1 and V2, the output will be the difference between V2 and V1. Why I am writing it as V2 minus V1 means V2 I am applying for the non-inverting terminal, V1 is applying to the inverting terminal. So it is V2 minus V1 is the output finally. But this will be depending on the resistance values what we have over here for the feedback and also at the input side. So to get the value of V0, we need to derive by taking the currents through the first input terminal, current through the second input terminal, and also current through the feedback network. And then after finding the voltage at this point, and then we are assuming that we are applying the voltage V1 and neglecting V2, means V2 will be 0. Let us take V1 into consideration. What is the output we are going to get? That is case 1. Case 2 is that by applying only the voltage from V2 and we are neglecting this V1. So V1 will be 0 and applying V2, what is the output we are going to get? By taking these two cases into consideration, and then we can add these two outputs. Once we add these two outputs, we are going to get the expression like this. This is V out. But this expression consists of R3, R1 components. If in case R1 and R2 are equal, means these two input resistances are equal, and R3 and R4 are equal, what happens? The expression of output will be reduced to R3 divided by R1 into V2 minus V1. If this R3 and R1 also equal, if we keep, what happens? Vout will be finally equal to V2 minus V1. This is what the perfect difference amplifier we are going to get when we are going to keep all these resistances equal values. Explain op-amp as an integrator circuit with an input and output waveforms using a square wave as input. So this is the op-amp integrator circuit. This question also asked in the previous question paper set 1. This is also very important. Here in the integrator circuit, if you take the inverting amplifier, inverting op-amp amplifier, just you need to replace the feedback resistor by capacitor. Then it becomes integrator. Here also you need to derive the expression for Vout or V0. Here it is Vout, here it is V0, this is Vout. You need to derive the expression for Vout. This is integration of Vin into dt. How we need to derive? Again by taking In and If into consideration. In and If are equal. We need to equate these two. Then we are going to get this expression. Output expression is this, and then we need to write the output waveform and input waveform for the square wave. If you apply the square wave like this, this is the output of the integrator we are going to get. So here you can clearly mention the time for the one complete cycle, and also here in the triangular wave how the time is going to be matched. Explain basic differential amplifier. Again the same question is asked in the previous question number 5. They have asked to explain the differential amplifier. Here also explain the differential amplifier. This question is same, it is repeated. Define op-amp parameters like gain of the op-amp, CMRR, slew rate and input resistance. Coming to the gain of the amplifier, always gain of any device will be Vout divided by Vin. But here in the op-amp, the same Vout by Vin is going to be taken, but there are two different type of gains we are going to consider. One is the differential gain and another one is the common mode gain. The differential gain and the common mode gain is that when there are two inputs in the op-amp, this Vin will be two types, Vin1 and Vin2, or we can consider it as V1 at the inverting terminal and V2 at the non-inverting terminal. So the difference between these two is there, means V1 is different and V2 is different. We are going to call that as gain of the differential inputs. When the two inputs V1, V2 are same, the same voltages we are applying, means these two are equal, then we say the gain which we are going to measure is common mode gain. And the second parameter CMRR, common mode rejection ratio of the op-amp. Here CMRR is the equal to AD, that is differential gain divided by common mode gain. Common mode rejection ratio is that it should reject the common signal if you are going to apply input terminal 1 and 2. So CMRR value can be calculated as 20 log AD divided by ACM. And then slew rate. Slew rate is the maximum possible rate of change of output with respect to time. So this is the expression and this is the unit we are going to say. This is input resistance. The next point, input resistance is Vin, voltage at the input side, to the current at the input side, that is Rin. So input resistance is defined as the ratio of input voltage to the input current expressed in ohms. So these are the typical values of the op-amp if it is FET or MOS device. This carries 8 marks. Each and every parameter carries 2 marks here. So no need to explain in detail. You can write the expression if it is there, and also you can write the explanation in one line. Explain inverting amplifier. So this is op-amp inverting amplifier they have asked. So here we need to apply the voltage Vin. This non-inverting terminal is grounded, and we need to derive the expression for this. Otherwise, if they ask only for 3 to 4 marks, no need to derive the expression. Just explain we are applying the voltage from the inverting terminal. So this is the input signal we are going to apply. This is, let me write it as Vin, and here we are going to get the output 180 degree phase shifted. This is 180 degree phase shifted output. Why? Because we are applying to the inverting terminal, and you can see here output will be minus RF divided by Rin into Vin is the expression, and gain if you take it is minus RF divided by Rin. Convert the following from decimal to binary. These are the decimal values they have given, and we need to convert decimal to binary. So these are the decimal values. We need to convert to binary, means we need to start dividing by 2, and the remainders we need to take from bottom to top. You need to remember this. So this gives this result. Here I have calculated. Please calculate once again for verifying these answers. And if it is a decimal part, 0.6875 is there, we need to convert into binary, means we need to multiply by 2 and we need to take this to the outside. It becomes 1. Again the decimal part we need to multiply by 2. So likewise we need to do for some 4 to 5 decimal places. Write down axiomatic definition of Boolean algebra. It means some laws and postulates of the Boolean algebra we need to explain. So here these are AND laws and OR laws, commutative law and associative law, and these are the different laws we are going to say with respect to Boolean algebra is considered. So you need to explain these things for 6 marks. Since it is for 6 marks, try to explain AND laws, OR laws, and also by taking 0 and 1 combination like this. Since this is 0 bar, 1 bar, this gives 1 and 0. So you need to explain this much for 6 marks. Simplify the Boolean function to minimum number of literals, means we need to simplify the expression to get the reduced number of terms in the expression. So this is the expression given. Here I am adding the missed term x plus x bar. This is easy for the simplification. So from this and this you can take xy as common. From this and this you can take x bar y as common. So it is reduced to y. This carries 3 marks. And similarly the second expression, here you just multiply these two, you can take the common factor. This expression can be simplified up to this much. This carries 3 marks again. Convert binary to decimal. So you can see one number system conversion will be there, from binary to decimal or from decimal to binary, from decimal to hexadecimal, and octal to decimal, like that. So since they have given in the binary, we need to convert into decimal. We need to multiply with the weights of these. Means this is the 0th term, first term, second term, third term, fourth term, fifth term. So we need to multiply by 2 by 5, 2 power 5, 2 power 4, 2 power 3, 2 power 2, 2 power 1 and 2 power 0. Finally we are going to get 55. Similarly for this, follow the same thing. 0, 1, 2, 3, 4, 5, 6, 7. So this is 1 into 2 power 7 plus 0 into 2 power 6. Similarly adding all, finally 0 into 2 power 0, like that. This gives 170. And this is a very simplest one, it gives 6. And now we have the next question, that is 100.1010. Now we need to convert that into decimal with base 10. We need to convert it into decimal. So we need to take this part separately, this decimal part separately. So for 100, again multiply with by taking this as 0, 1, 2 position, and this is minus 1, minus 2, minus 3 and minus 4 position, and do the same thing. We are going to get the final result like this. We need to add these two, 4 plus this we need to do. Finally we are going to get this. Explain SOP and POS with examples. First say what is SOP and POS. SOP is sum of the product terms and POS is product of sum terms. Means suppose if we have two terms like this and we are adding these two, and these are having products, like this is A into B plus C into D. This will be a sum of two products. This is a sum of two products, we can say. So product of sum will be in the same kind. A plus B, this is a sum. We are taking a product of another sum. So this is sum and this is sum. This is a product. So you need to take any example like this and write a circuit so that this carries 6 marks. Implement half adder using basic gates. In these questions carefully you need to observe. Here they have asked basic gates. Only you need to use AND gate, OR gate and NOT gate. You are not supposed to use any other gates while implementing if they have asked basic gates. Otherwise, if they ask implement half adder using logic gates, you can use any gates you want. Here half adder, write the definition. Sum and carry expressions are these. You need to write the truth table. Here sum will be A bar B plus A B bar. It is A XOR B. You can use simply, you can write it as AB with XOR gate. You can implement it using one XOR gate, but this is wrong. They have asked to use only basic gates. So basic gates need to be used while implementing. Explain the working principle of capacitive transducer. The capacitive transducer is asked. First you need to write what capacitive transducer is. Means the capacitance variation will be taken as a principle of measurement here. Because of the variation in the capacitor value, so we can measure the displacement, pressure or other physical quantities. So with that explanation, you need to write the capacitance expression, equation for capacitance between the two plates, and these are the different terms, and where and all these things are going to be used you need to explain. Here physical phenomena of working is very important. That carries maximum marks. 3 to 4 marks will be given for the explanation how it works, and also this relevant circuit, and also you can write some other circuits if you know with respect to the capacitive transducers are concerned. And explain working principle of piezoelectric transducer. Again here the piezoelectric effect you are supposed to explain, how piezoelectric sensor when the pressure is applied, how the crystal is going to generate the output voltage. And here the second part of the question is write the applications of piezoelectric transducer. First part is working principle, this carries 4 marks, and next 4 marks for the applications. So at least you need to write 6 to 7 applications or 5 to 6 applications, that carries 4 marks. Write down the applications of thermal transducer. Here just they have asked only applications, no need to explain the how thermal transducer is going to work. So thermal transducer in the sense it is a temperature sensor or temperature transducer. So temperature transducer where and all we can use in the variation of temperature that need to be monitored to control the temperature to high or low. So these are the different examples or the applications of this you can write. So for 4 marks you need to write 4 to 5 applications with some explanations. Don't only write 1 or 2 words for the applications, just try to explain what they are going to do. And the 10th question, last question, explain typical radio transmitter with neat block diagram. This is the block diagram of radio transmitter. In the 5th unit you have a communication system. In the communication system we have a block diagram and also radio transmitter block diagram. Out of these two, one question will be asked in the exam for sure. So since it is a communication part, out of these two, one communication will be asked. So here this path is a carrier chain, how the carrier is going to be added, and this is the audio section. First in the mic, audio will be taken into electrical form and there will be a power amplifier, and then modulated class C power amplifier is there here for mixing, and here the carrier oscillator generates the oscillations, that is carrier signal. There will be buffer amplifier, frequency multiplier, power amplifier, and then we will be transmitting that through the transmitting antenna. So you need to explain these things briefly for getting 6 marks. And what is modulation? Explain the need for modulation. Again in the previous paper also this question is asked. This is very important. First you need to write the modulation definition carefully. What happens when the modulation takes place? Modulation is a process of varying one of the parameters like amplitude or frequency or phase is going to be varied. Which signal phase amplitude is varied? Carrier frequency or carrier amplitude or phase is varied by looking at the or in accordance with the modulating signal. So these are the different types of outputs we are going to get if we choose AM, FM and PM. And need for modulation is asked here. Need for modulation is very important. This is asked many times. So here we need to explain, if we do the modulation, we can reduce the height of the antenna. If modulation is not there, antenna height will be higher. So we can't put the antenna to the higher distance communication. So avoid mixing of signals. It increases the range of communication. Multiplexing of signals is possible and it will increase the quality of the receiver. So these are the things you need to explain in brief to get full marks. Since it is asked for 8 marks, you need to explain these. You need to explain. Don't put the points like this. You need to explain with little bit of explanation. The last question is, what is noise? Explain the term channel noise and its effects. First you need to write the definition of noise. Noise is always an unwanted signal. Even in the communication, this noise will be added up in the channel. So there will be a channel, noise will be shown over here like this. So In the channel, noise will be added up with the required signal. There will be an original message or the modulated signal transmitting through this channel. When the noise is added up, what happens? That is the question. So noise is an unwanted signal which disturbs the signal or corrupts the parameters of the message signal. This carries 1 or 2 marks. This is for the first part. So effects are, noise limits the operating range of systems. So different frequencies we can't process if the noise is going to be added up. It limits the smallest signal that receiver capable of processing, and also affects the sensitivity of the receivers, and also it eventually affects the output signal finally, and leads to message itself getting altered. So these are the different effects, and if you know, you can add up 2 more points over here. Try to write 4 points, and here this carries 1 marks, and also you need to explain what is channel noise carries 1 mark and effects carries 4 marks. So this is about the answers for set 2. You can see in the playlist set 1 and set 2 complete answers are given, and you can follow the different videos present in Introduction to Electronics playlist also with Basic Electronics for more information. Thank you.